All right, what is a Condorcet winner? Okay, so if you hold an election with a preference schedule, there may be a Condorcet winner, there may not. Okay, but what is a Condorcet winner? If one candidate is preferred over every other candidate by 1-on-1, which is called pairwise comparison. In other words, if if A and B are the only candidates, how many people would prefer A over B? How about A over C? How about A over D, and so on? And if one person stands out as being preferred over all the other candidates, that candidate is the Condorcet winner. And according to the Condorcet method, that person shall be declared the winner of the election. I explain how the border count method determines the winner, how the border count method determines the winner of the election. So border count is counting, right? Counting what? Counting the number of points that is obtained by each candidate. So each last place vote gets 1 point. Each second to last place vote gets 2 points, etc. Okay, and then if there are 5 candidates, then the top vote gets 5, and so on. It depends. I see that we have seen a couple of examples, and sometimes the top candidate or the number 1 candidate gets 5 points, sometimes 3. But that depends. What we traditionally do is the last place vote gets 1, and then it increases by 1, right? Second to the last gets 2, a third from the last place gets 3, and so on, right? So for each candidate, the total number of points is calculated, and the one with most points, of course, wins, okay? If you are a fan of soccer, which the rest of the world calls football appropriately, in the first round of the World Cup, when they have 32 teams coming together to one place, right? And they have this, these group plays where everybody, well, each team plays everybody else in the same group, right? And if your team wins a game or match, you get the team gets 3 points. If it's a tie, each team gets 1 point. If you lose, you get 0 point. And that's a point system, which is like a modified border count. And then the top 2, the teams with top 2 points, or 2 top teams with many points or the most points, will advance to the next round, the single elimination round. So that is a modified version of what we call the border count. Okay, number 18. A city has 3 major events on the 4th of July weekend. You have a parade, a seaside party, and a soccer game. The number of people in each event will attract the number that each event will attract is shown below. The city wants to send 400 police officers for security purposes. Determine how many officers. So this is what an apportionment problem, right? How are you going to distribute the 400 police officers as resources to these events? And of course, the larger the crowd, the more officers you want to have. Determine how many officers should be assigned to each venue, including or using Hamilton's method. All right, so let's go ahead and do this. The first thing you have to do is to find the divisor. It looks like the total number is 72,000 people in all the places combined. How many officers are available? Will be available? 400. You take the division. 72,000 divided by 400 is 180. All right, so it means approximately you want to have about 180 officers. Sorry, 180 people per officer. Okay, that's what we want to have. So then we take these numbers and then we divide it by 180, right, to get this next number here. So this number right here would be 40,000. Maybe I should write this down. You don't have to write this down. Of course, when you are doing this problem on your test, you need to show your work. So you should write this down somewhere. You divide this by D, the divisor, the standard divisor, and this will be 224.166, and so on. Make sure you use your calculator for this. Same thing here, you divide this by 180 and you get 47.5, exactly. Let's go ahead and write 500. 23,100 divided by 180 is 128.333. And then of course, this you don't have to worry about. This divided by 180 will be 400. And that is the sum of all of these numbers also. But that doesn't really mean anything. So you don't have to fill this part. The minimum quota. So forget all the parts after the decimal point. This is 224, 47, 128. So this is the least number of officers that should be assigned to each site, right? If you add them up, you get 399. And you say, okay, we need one more officer is available. Let's give that officer a break. Let him or her stay home and enjoy. Well, no, I mean, you could do that, but in the apportionment problem, you're supposed to use all available resources, including that last officer. The question is, where should the last officer be sent? And according to Hamilton's method, which sometimes produces that Alabama paradox, but if you simply apply that, you just compare the remainder part. Let's look at the remainder. What did we throw away? 166.500, 0.33. This is the biggest one. So then we add 1 to this number. The seaside party will get 48 officers. The other 2 will stay the same. And that, because we added 1, will be 400. And we are done. Okay, so in this case, the seaside party site or the venue gained an advantage because the quota had a decimal part, which is bigger than the other 2 venues. All right, number 19. Now, same thing. In fact, it's exactly the same numbers here. Let's use Jefferson's method to see how many officers should be assigned to each venue. The answers will be kind of similar to this, but they may be off by 1 or 2. Now, theoretically, you're supposed to come up with a number that is going to work. Okay, now I use 180. Okay, so let me go ahead and do this. If I try to do this 180, you get this, right? And so you, of course, always truncate, you round down, so you will end up with 399 just over here too. Okay, and then of course you have to not worry about the remainders in Jefferson's method. In Jefferson's method, instead of using the remainders, you start dividing by lesser numbers, not 180. So you can try like 170, and you find that it's way too small. Okay, so it turns out this number should be modified just a little bit to make the number come out right in the bottom. And so, and again, it's a trial and error. There is actually an algorithm to find this, but there is a number that would work. And I will give you the number will be given to you so that you don't have to keep trying a bunch of numbers, right? So try the divisor, the new divisor. This is the modified divisor, which will work. And that would be 179.2. So what am I doing? I'm dividing all of these numbers, each of these numbers divided by 179.2. And the answer here would be 225.17. Okay, now, but yeah, and then this next one will be 47.71 and then 128.91. This doesn't matter because that is meaningless. If you look, and then the number of officers, you round this down, and basically you truncate, forget everything else after the decimal point, and then you find out what changed. See, if you look at these minimum quotas, it's 224, 47, 128. Over here, 225, 47, 128. So this first one, parade, gained an extra seat. Okay, and the number actually changed rather quickly from 224.166 to 225. And the reason this went up so quickly is because this number is actually a big number. In fact, parade has the biggest crowd, right? And so this, again, underscores or illustrates the fact that Jefferson's method favors large state or large crowd. Okay, so that extra officer is sent to the parade according to Jefferson's method. All right, so that's number 19. All right, and then let's go to number 20. Now this is a big chunk, so I'm going to do all of these, and it's going to take an entire page, but listen carefully. Number 20, a labor union is considering 3 healthcare plans, A, B, and C. Very important topic for any union. The 100 members vote by ranking the 3 plans. Okay, now they could decide to choose one of the 3 plans and just vote on just one. In that case, you are using the plurality method, and all you will see is this. You wouldn't see any rankings. This is all you see in the plurality method. Right? So who is the winner by the plurality method? Well, 22 people would say A is the best. B, remember, you have to add up these 2 numbers. So 28 plus 10, that's 38 people casting their ballot for B, and C, whoa, it gets 40 first place votes. So C wins if it were the plurality method that is used. Next one, who wins by the instant runoff voting method? Now this one is tricky because it is multi-step. All right, so follow along carefully and patiently. In the instant runoff voting, which is IRV, the person with, or the plan with the least number of first place votes is eliminated first, right? Take a look at this. A is eliminated or removed first. Why? Because A only has 22 first place votes. The other ones have more. So A is removed first. And if you remove A, this is what's going to happen to the schedule, right? And so you see BC, 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 and CB. And in a sense, you can combine all of these things because they will all be BC, right? So you have B, C in this order. And then the only other alternative is CB. 40 people support that. All the other ones, if A is eliminated, is still going to prefer B over C. That's 22 plus 28 plus 10. That's 60 people favoring B over C, right? So then C gets eliminated and then B wins. Then C is removed. So B wins according to the instant runoff voting method. And some people argue that this is more preferred, or this is fairer than just the plurality method, because it does consider people's opinions for those who may not be the first place choice. C, is there a Condorcet winner here? Okay, so let's look at this. Now, we already established that B is over, B beats C. How do we know that? Well, because we forget A, and then we found out 60 people favors B over C, only 40 people favors C over B. So B beats C by 60 to 40. Now, instead of comparing A to C, I want to see B is already partially a winner. B is wins over C. So if B is over, or if B beats A, then the question is done. We don't have to worry about C and A. Who wins between C and A. So let's try to see B versus A. Okay, so again, what we do is this. When we look at B and A, we pretend like C did not exist. Let me just show you what I do on the chart itself. Yeah, so if you pretend like C didn't exist, you can even cross this out, like this. And so if you take a look at this, you have AB, and then you have BA, 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 right? So except for the first column here, where 22 people prefer A to B, all other people prefer B to A. Now you can add 28, 10, and 40, and that's 78. Of course, these total always will be the same, 100, because you have 100 people voting here. But so guess what? So B wins over A by the score of 78 over 22. It looks like a landslide, right? B is preferred over C by 60-40. B is preferred over A by 70 to 22, and therefore not B, not A, B wins. So B is the Condorcet winner. Now, remember, we are not just looking at how many first place votes we got, and that's what sometimes students do. We are not just looking at the first place votes. When we are to do Condorcet, you really have to do pairwise comparison, assuming that nobody else exists. And so for each column, you have to say how many people prefer A to B or B to C or something like that. That's the way to do that. So, again, pretend like nobody else exists when you do that. Okay, part D, use the border count method to determine the winner. To save you time, so what you have to do here is border count, right? So every time a person gets a first place vote, you have to award 3 points, right? The third place gets 1. And so you have to now start counting, right? So for instance, technically, this is what you'll have to do. Let me go ahead and erase everything. So A gets 22 times 3, right? A gets 22 times 3, and looks like A gets 10 times 2, and then A gets, so 28 plus 40 is 68. 68 times 1. You add them together, right? B gets here is 38 times 3, and B is here and here. That's 62 times 2, and so on. So you have to do manual calculations. On an exam, if I ever ask you a question on border count, just to save you time, because your exams are limited, I will probably just sort of reorganize this for you, the data for you to save you time. The numbers of third, second, and first place votes on each sport. These are plans. For each plan are summarized. Okay, this must be from another problem or something. All right, so what do you mean by that? Well, A gets a 68 first place votes, and that comes from, A gets 68 third place votes, and that comes from 28 people in the second column and 40 and third and so on, right? And so I am summarizing this for you. So all you have to do is to calculate, right? So 68 times 1, that's the number of points A gets for being third place. And then you have 10 times 2 for the second place. And then you have 22 times 3 for the 22 first place votes. If you add them together, you get 154, right? B gets 1 points, and 62 times 2 points, and 38 times 3 points. That adds up to 238. C gets 32 times 1 point, and 28 times 2 points. Now it gets a lot of 3-pointers. 40 people vote for C as first place, and so that itself is 120 plus this and this, and then you find out this adds up to 208. So guess what? B again becomes the winner under the border count method. All right, so it looks like C wins first, and then B, B, and B. Now, of course, you only are going to use one of these methods, and that method should be decided before the election takes place. And so you don't get all of these choices. You have to decide which one to choose to adopt in declaring the winner before the ballots are cast. Okay, so that is number 20. So we will start the next segment with problem number 21.